Hello students, how are you all? This is your KP sir, Krishna Prakash. So we are continuing the series of questions, concept through questions, objectives from environmental engineering subject for TSPSC, BPSC, GATE 1 mark, ESE engineering service exam, SSC staff selection commission, all state AEAA. So this series will help for all the state exam preparing students, staff selection commission students, for whoever preparing for the examination. This will be more helpful. I'm explaining little theory as well as the questions because I am explaining the theory surrounding the question. Because environmental engineering is such a subject where theory is very important. And in that vast bundle of theory, we feel that which is very important, which is not very important. We feel that. So what is important we are discussing here. So this much theory, this much questions are enough for your state exam preparation, SSC JE, for this subject of environmental. So if you want to follow me, follow on Unacademy special classes, use the code KP Civil, scan the barcode. You can get a special class and YouTube notes everywhere you are getting if you scan the barcode. And also you can get information related to KPSR classes. Follow me in Unacademy. And remember, if you want to get regular intervals about the links, classes and everything, our Telegram channel KPSR Students. Okay. Our code is KP Civil and our Telegram channel is KPSR Students. And you can message me through Telegram KP Civil. You put KP Civil in Telegram, you can get it. You can message me directly, personally also. So guys, we are here to discuss regarding our preparation. Now the topic is water demand. We are here to discuss the topic, discussing water demand. So there are lot of theory questions in water demand. I filtered for you. I made for you the most important theory questions. So we can go ahead now. The average domestic consumption of water in a city under normal condition. The average domestic consumption of a city under normal condition. So that is 135 LPCD. So domestic consumption as per IS 1172 code book. Domestic consumption for HIG and LIG. Like this we can write low income group 135 LPCD. High income group we can write 200 LPCD. But they never ask in our state exam or any exam questions HIG, LIG. They will ask either minimum or average. So if they are asking about minimum, if they are asking about average, your answer is 135. If they ask about maximum, you go with 200 LPCD. By chance they are asking maximum domestic consumption and in the option there is no 200. You can go for whatever maximum value in the options you can select. It may be 150, it may be 175, it may be 180, whatever the maximum value, or nearby to 200. 210, 220 also, you can take that for maximum water demand. Now the question is average. For average and minimum, we'll take 135 LPCD. In the case of public water supply system, requirement of water supply system for fire demand. For fire demand, when you take water requirement to extinguish the fire, to stop the fire accident, it is generally taken as a direct function of. Means when you are designing a public water supply project, you don't know how many fires going to happen. How much huge fire accident happened, you don't know about it. So while designing for fire demand, what you take as a direct function of. So as a direct function of population of the city. It's not about number of multi-storied building. It's not about industrial area. It's not about area of the city. Because you take any empirical formula, Cushing's formula, Boston's formula, Freeman's formula, NBFU formula. Everywhere we are taking some factor into root P something. So it is directly related to population of the city, not related to how many multi-storied buildings are there, how much area of the city, how much industrial area. It's not at all related. It is always related to population. Then requirement of the water is highest for livestock, irrigation, domestic needs, nuclear power plant. So requirement of water highest among given options. Please understand this point. Among the given 4 options, highest is for. Highest is always for irrigation water needs. Agricultural land is very huge. So consumption of water for agricultural needs is very huge. So always we choose among, always not consider among the given option. First priority irrigation, second priority domestic need, third priority livestock, fourth priority nuclear power plants. So when compared to given options, when compared to domestic needs, irrigation needs more water. So your first priority irrigation, second domestic need, third livestock, fourth one nuclear power plant. Water losses in a supply system are assumed as water losses in a supply system 15%, 7.5%, 10%, 22.5%. So generally we have what we can take generally. Generally we have water losses taken as 10 to 15%. Both given. Please understand, water losses, generally losses and thefts we are having. Losses and thefts we are having, included thefts also, losses and thefts will take 10 to 15%. We'll take it as per IS 1172, 55 LPCD of total. 55 LPCD of total will take. Now, they are asking either 10% or 15%. So, you can go with maximum. You can select the maximum, that maximum is 15%. Okay? Out of total water losses, thefts, whatever maximum you can go, 10 to 15%, you go with 15%. Design period adopted for designing a water distribution system. A water distribution system is designed for. In water distribution system, you have pipes, valves, reservoirs, firefighters, pumps, so many things are there. Each and every component have its own design period. We'll take pumps only 10 to 15 years. You take CI pipes 100 years. You take reservoir 30 to 35 years. Like that it will vary component to component. But as a whole you are talking water distribution system. You select 30 years is as a whole for distribution system. Not only for water distribution system, for our water supply project, for most of the civil engineering projects, for most of the constructions, on an average will go for 30-year design period. Per capita consumption of water of a locality is affected by one locality per person consumption. They are talking about not total consumption. Individually per person consumption, per capita demand, per capita consumption of a water for a locality. Climatic condition and quality. Yes, truly climatic condition and quality. But don't stop here. Go ahead. Quality of water, distribution pressure. Distribution pressure is more. Losses and thefts will be more. Per capita consumption also will be more. You feel like that? Distribution pressure, climatic condition. So, climatic condition, winter season, summer season, rainy season. It will vary. It will vary. Consumption. Per capita consumption will vary compared to winter season, rainy season, summer season. Quality of water is good. You consume more water. But distribution pressure, when you consider, Distribution pressure is depending upon whether you are supplying perennial supply or intermittent supply. Pressure is more, losses are more. So you can go with all the three. Climatic condition, quality of water, distribution pressure. Because you are talking per capita consumption of a locality, total locality, total per capita consumption. Total per capita consumption will may vary with respect to climate, quality and distribution pressure. Coincident draft of water during firefighting. Coincident draft of water during firefighting is represented by. So CID, generally what is the formula? Coincident draft. CID, maximum daily demand plus fire demand. Maximum daily demand plus fire demand. So here fire demand not included, only the remaining one, maximum daily. You can include maximum daily, that's it. Because it is not included, what we can do? We can't do anything. You can go with maximum daily demand. Freeman's formula to estimate quality of water, quantity of water required to meet fire demand. Freeman's formula to estimate fire demand with a population of P. So before going to show you Freeman's formula, I will show you this. So NBFU 4640 root P into 1 minus 0.01 root P. Freeman's formula 1135.5 into P by 5 plus 10. 1135.5 into P by 5 plus 10. Cushling's formula 3182 root P. Boston formula 5663 root P. In every formula, discharge is liter per minute. LPM, liter per minute. Population will be taken in thousands, every formula. And those who are preparing for GATE and ESE, mostly these questions, empirical formula for fire demand, as of now up to 2022, there are no questions. But state exam required, SSC JE required, BPSC sanitary engineer jobs required. These kind of exams needed compulsory. You need to by heart the empirical formula for fire demand. So this is Freeman formula. Please check the options given. 1136.5 into P by 5 plus 10 LPM. This is Freeman formula. That is Freeman formula. Okay guys, we'll move on. The distribution means in a water supply scheme are designed for. Distribution mains are designed for. It is given distribution main which is greater of B or C. Maximum hourly demand. What is maximum daily demand plus fire demand? Sum. Maximum daily demand and fire demand sum. What is it? Coincident draft. CID. So distribution mains in a water supply are designed for either coincident draft or maximum hourly demand, whichever is maximum. Greater of the two. Greater of the two. Per capita demand of water is given by. So per capita demand of water is given by. Please understand this question. You take Q is nothing but annual volume. As per their meaning, even though not required, not given. Annual volume. Q is annual volume. So you take annual volume per capita means divided by population into 365. Annual volume in liter per year divided by 365 year to day conversion. So liter per day. Got it now? Q is annual volume liter per year divided by 365 liter per day per capita. So we need liter per day per capita divided by population. So option A, Q upon P into 365. Annual volume of water consumed divided by 365. Daily volume consumed, liter per day. Divided by population, liter per day per capita, LPCD. As per Booston's formula, what is Booston's formula? Booston's formula for fire demand, Q is equal to 5663 root P. For a city of population of 1 lakh, fire demand will be. Population is 1 lakh, but 1 lakh in thousands you have to take 100,000. This is important. 1 lakh in thousands you need to take, that is 100,000. So 5663 root 100. What you are getting the answer? 56630 liter per minute, LPM. Simple question, but you need to remember the factor of Booston that play a very important role. 56630 liter per minute, option. You know it now. Already I told, fire demand empirical formula mein discharge is coming in liter per minute. Population must be taken in 1000. 1 lakh converted to 1000, 100,000. V is a total consumption of water in liters for n individuals. V is the total consumption of water in liter for n individuals. Per capita consumption will be. So same previous question. V, annual consumption, 365 days, population. But population is nothing but n, they told n. So change P to n. V upon 365n. V upon 365n. V is the total consumption of water in liter for any individual. The per capita consumption, V upon 365n. Consider following statements. The daily per capita consumption of water apparently increases with. Every day water consumption apparently increases with. Daily per capita consumption apparently increases with. Increase. High standard of living of people. Yes. People's standards of living increased means they consume more water. Availability of sewerage. Sewerage is nothing but a drainage facility. You are consuming water more. So wastage more. You are taking more water for bath. Shower bath you are taking. You are taking bathtub. But at the same time, the consumed water will drain off. You are using more water for washing off clothes. You are using more water for washing off utensil. To drain the water, there must be a drainage system, sewerage system. Otherwise, water will getting stored. No water going on, you can't consume. So that excellent availability of drainage system required. Metered water supply. In metered water supply, cost or water bill given per consumption. If you are consuming more water, you are paying more water. If you are consuming less water, you are paying less amount. So, based on consumption, metered water supply is cost based on consumption. Metered water supply is a cost based on consumption. Then ultimately people will consume less because they have to pay more. If they consume more, they have to pay more, so that they will consume less. But what they are asking? They are asking about increase, not decrease. So, if they are costing as per consumption, for example, you are consuming 10,000 liter. 10,000 liter into 1 rupee, if I say, for example, 10,000 rupees. Then surely you are reducing consumption. You are trying to consume only 2,000 liter, 3,000 liter, not 10,000, 20,000. So it decreases. So metered water supply cancel. Then good quality of water, wholesome and potable quality of water, true. Answer is 124. So you understand two systems of water supply. One is a metered water supply, like current electricity consumption per consumption basis. Second one, litered water supply. You can consume any number of liters, but cost is the same per unit basis. Per 1 meter, you are paying that much every month, same bill, not varying bill. But in metered water supply, meter will be there, but every month varying bill like our electricity bill. That is metered supply. In a city having population of 1 lakh, fire demand in liter per minute as per Cushing formula. Cushing formula, Q is equal to 3182 root P. Then what is population? Again, population 1 lakh. 1 lakh is 100,000. 1 lakh is 100,000. So substitute that 100. 3182 root 100. 31820 liter per minute. 31820 liter per minute. So you are getting it, 31820, Cushing's formula. Chalo. Average weekly demand in a city is Q units. The maximum weekly demand will be. Maximum weekly factor is 1.48. We studied factors individually. Maximum monthly, maximum daily, maximum seasonal. Or else you take from Goodrich equation. From Goodrich equation you can calculate it is 1.48 also. So that maximum weekly formula 1.48 into average weekly 1.48. Coincident draft is. Coincident draft already we have written. Maximum daily demand plus fire demand. CID, maximum daily demand, Qmax daily plus fire demand plus FD, fire demand. What is Qmax daily? Qmax daily is 1.8 into average. So 1.8 into average plus fire demand, that is coincident draft. So all questions related to water demand, maximum questions I put here. These are most expected. I hope you enjoyed the session. Like, share and subscribe the channel and make your friends to attend and to follow your beloved KP sir. So you know our Telegram channel is KP sir students. Let your friends to join and yourself to join in this KP sir students channel. You want to talk with me personally, my Telegram name is KP Civil. You want to take Unacademy subscription, you want to refer your friends for Unacademy subscription, you know our universal code, KP Civil. Let's crack it.